In the previous section, we mentioned De Morgan's laws, but now we're going to take a closer look at them. We're going to examine De Morgan's laws for the union complement and for the intersection complement. The union complement rule is A union B complement is equal to A complement intersect B complement. Notice the pattern. We're distributing the complement and we're changing the direction of that sign. To understand how these are equal, we can shade a Venn diagram to see that these two sets are the same. Let's examine the set on the left, A union B complement. We know that A union B is everything inside both circles, so the complement is going to be everything outside those two circles. So I'm just going to shade the region outside those two circles. That's going to be A union B complement. Let's compare it to the set on the right. A complement intersect B complement. Now this one we're going to have to work up to with our shading process here. I'm going to start and shade A complement. I'm going to do this in green. A complement is everything outside circle A. So I'm going to be careful to stay outside circle A. And then B complement is everything outside of circle B. So this time I'm going to shade in blue and I'm going to stay outside of circle B. So A complement is in green, B complement is shaded here in blue. Now, if I want to find the intersection of those two sets, I want to figure out what those two sets have in common. So I'm looking for the area that has both directions of shading. So do you notice the region that has both directions of shading is the same as what we have over there on our first Venn diagram? So the shaded regions are the same. Therefore, A union B complement is equal to A complement intersect B complement. Let's look at the intersection rule. The same pattern occurs. A intersect B complement is equal to A complement union B complement. So I'm distributing the complement and changing the direction of the signs. Let's show that these two sets are in fact equal using the shading technique on a Venn diagram. Now, let's look at A intersect B. We know that A intersect B is this region here, the overlap between circles A and B. So the complement is going to be everything except for that region. So I'm going to shade everything outside of that intersection. Now, let's do our color shading technique over here. Let's look at A complement. Now, remember, A complement on this diagram was green and B complement on this diagram was blue. Instead of looking at where the two shadings overlap, now I want to put those two shadings together in both circles. So looking at this one and changing our perspective from intersection to union, we can see that everything except for that innermost region has been shaded. So again, we end up with a region that matches our first region. Thus, De Morgan's laws govern the complement of a union or an intersection. If you have a union or an intersection in parentheses with the complement on the outside, distribute the complement to each set, and then switch the direction of your operation. This distributive property also applies to something like this. Is A union B intersect C equal to A union B intersect B union C? Now, I know it looks like alphabet soup, but notice what we're doing. We are distributing A union to that first set. So A union B ends up right here. And we're distributing A union to this second set. And the intersection here is an intersection here. Let's see if that works. Okay, let's shade the region indicated by the set on the left and the set on the right. So starting with the set on the left, we're going to shade the region indicated by A union B intersect C. Let's start with B intersect C. B intersect C is what B and C have in common. Now I'm going to unite that with A. So this shaded region is now going to extend and include circle A. So this shaded region represents A union B intersect C. Let's see if it's the same as what we have over here. A union B, let's do two colors. A union B is everything in A together with everything in B. So A union B is shaded in blue. Let's shade B union C. That's everything in B together with everything in C. Now I want to find out, what do those two sets have in common? Where do those two shadings overlap? So the region that contains the two overlaps is this region right here. Okay? Now let's compare. Does this region look exactly like this region over here? Those two are not equal regions. So the answer is no. How do you suppose we might apply De Morgan's laws to something like this? Remember, we distributed the A union, but we kept this intersection sign right here. An equivalent set would be A union B union B union C. That is, I distribute the A and flip the sign over here. Now, don't be intimidated by De Morgan's laws. I want you to be familiar with them. We will see these again applied to logic, but they're actually going to be pretty simple in your homework.